Okay, problem number 7, compute. These are the problems I'm going to miss, so be careful of my arithmetic. The first thing we want to do is to do a scalar multiplication of a vector. I know how to do it, but again, keep track of my arithmetic. 2 times the vector 3, 1, 2 will be the vector 6, 2, 4. Now I want to take the vector 6, 2, 4 and add to it negative 1 times the vector negative 1, 2, 1. So that will be the vector 6, 2, 4 plus 1, negative 2, negative 1. When I add them, I get 7, 0, 3. Now I want to do a matrix multiplication. And in this case, I'm trying to take a 3 by 2 matrix times the vector. It's actually matrix vector multiplication, so it's times a vector of size 2, and I'm going to get a vector answer in the end. One of the things that I notice is that what I can do here is I can take 2 times the vector 3, 1, 2 and add to it negative 1 times the vector negative 1, 2, 1 in order to do this matrix vector multiplication. Why will that be nice? Remember, I make a lot of computation errors, and I noticed I already calculated 2 times 3, 1, 2 earlier in the problem. And I think I've calculated the negative 1 times negative 1, 2, 1 properly. So this should give me the same result as part B did, 7, 0, 3. Make use of what we already know. Let's try the next one. Okay, I want to do the dot product of this vector with this vector. And so it's going to be 3 times negative 1 plus 1 times 1 plus 2 times 2. So that's negative 3 plus 1 plus 4, which will be positive 2. Now let's see what we have here. It's again the dot product of this vector and this vector. It's going to be negative 1 times negative 1 plus 2 times 1 plus 1 times 2. That's going to be 5. Now what I want to do is a matrix vector multiply again. Notice really what I have here is the matrix 3, 1, 2, negative 1, 2, 1 times the vector negative 1, 1, 2. So the product is actually going to be a vector of size 2. And so, but I noticed that the way to get it is the first component is going to be the first row of this matrix times the vector, but that's actually the first column. So it's the dot product of the first column here with the vector. Oh, I already calculated that in part D. That was 2. And the second component here will be the dot product of the second column with the vector. I already calculated that. And so the result is going to be the vector with components 2 and 5. I saved myself some arithmetic. Let's try the next, and hopefully I'll be able to do similar things there, but I don't think that's going to work. I want to find the 2 norm of the vector 3, 4. Well, I know to find the 2 norm, what I do is I take the dot product of 3, 4, that vector with itself, and then I take the square root of that result. So that's going to be 9 plus 16 is 25, and the square root of 25 is 5. So the 2 norm of the vector is 5. Now I want to take and multiply a matrix times a matrix. Notice that this matrix had 2 rows, 3 columns, and this one has 3 rows, 2 columns, so they are conformal and I can do the product. And the result is going to be a 2 by 2 matrix. And that means it's going to have 2 rows and 2 columns. If I want to figure out this first component, what I can do is I can take the dot product of the first row here with the first column here. So that will be 3 times 3 plus 2 times 4 plus 1 times -1, which is 9 plus 8 minus 1, or 16. Here, this component will be the dot product of the first row, second column. So that will be 3 times 2, which is 6, plus 8 plus 1, which is 15. This component in the matrix is going to be found by taking the dot product of the second row with the first column. That's going to be 12 plus 16 plus 1, which is 29. And this last entry will be found by taking the dot product of the second row with the second column, and that will give me 8 plus 16 minus 1. 8 plus 16 is 24, minus 1 is 23, so if I did my arithmetic right, I have the result. Now I want to take this matrix transpose by this matrix transpose. I wonder if it's this matrix transpose. Well, let's think about it. What is this matrix transpose? That would be the matrix with entries. Well, it's going to have a first column of 3, 2, 1, and second column 4, 4, -1. The transpose of this matrix is going to be the matrix with first column 3, 2, second column 4, 4, last column -1, 1. So this is actually a 3 by 2 matrix. This is a 2 by 3 matrix. So the result is going to be a 3 by 3 matrix. Definitely not just the transpose of this one. So good thing I didn't just try to write down the answer. So now, how am I going to get the results? There are going to be 9 different components that I'm going to need to find in my solution. And so the first component can be found by taking the dot product of the first row here with the first column. That will be 9 plus 8, or 17. This will be the dot product of the first row second column, which would be 12 plus 16, which is 28. Then I'll have the first row last column, which is -3 plus 4, which is 1. Then I'll have the second row first column, which will be 6 plus 8, or 14. The second row second column is going to be 8 plus 16, which is 24. And the second row last column will be -2 plus 4, which is +2. Now the last row is found by taking the dot product of the last row of the first matrix times each one of the columns. So the dot product of the last row with the columns. So we would have 3 plus -2 is +1. 4 plus -4 is 0. And then -1 plus -1 is -2. And that will be the product of the 2 transposed matrices. So if I transposed the matrices and then I took the product, that's the result I would get.